Welcome everybody to the webinar Best BIM Practices for Sharing Models. We're going to focus on a few items today. The itinerary, as we're going to go through it, is going to be relatively structured, but you are welcome at any time to break in with a question if you have questions, and then we can discuss that as we go along. So our agenda this morning will be to look at access to the common data environment. We will be focusing on the Autodesk common environment, which is called BIM 360. But at the same time, we must also be aware that there are other common data environments. Something like Oracle Aconex would be a good example of one such environment, although there are many others. And they are used in the industry for various reasons, but mostly what they work off is something called IFC, and you can see at the bottom there we discuss IFC last. But just understand as we learn about the process today that some common data environments only exclusively work through the IFC file or the Industry Foundation class file. We're going to see why we work in silos. So what we mean by that is we keep disciplines separate from each other, and then what sort of roles and responsibilities we have, and the advantages of using BIM 360 Design and BIM 360 Coordinate. If you're not familiar with them, BIM 360 Design is a license from Autodesk which allows you to follow the sun, and that will allow you to work in collaboration with other people anywhere around the world in the same file at the same time. And that's specifically for Revit. Similar functionality exists for Plant 3D, Civil 3D, and InfraWorks, albeit not to such a collaborative extent, but you can still use it as a repository for the files, in which case you can have your team members being at home and being able to access a common folder where the files are stored. We're going to look at how we prepare models for sharing. There's a typical checklist that we follow. How we would use something called model checks, which we can find within the BIM interoperability tools, and then what is IFC and how is it used. So starting off with the Autodesk Construction Cloud, there we can see that it's cloud-based first of all, so there is only one source of truth. This is usually where a lot of trouble can be avoided. The worst example that I've seen where Dropbox and emails have gone wrong, I've seen a MEP department working on a week-old file, in other words, the wrong file, for an entire week. So all the engineers and the draftspeople, everybody did work for an entire week on the wrong file. When you base your files on the cloud, you do not have this problem because you are guaranteed that that file is the most current file. Then there's something called the Autodesk Construction Cloud. Andrew Anagnost, the Chief Executive Officer of Autodesk, has focused the products on the build side very specifically geared towards the cloud. The reason is because somewhat of 60% of the world's energy is used within buildings worldwide, and because Autodesk is very interested in sustainable development and just making the world a better place in general, and because we are urbanizing at such a rate, it's seen not only as a lucrative market but also as a responsible decision to take to try and get everybody to work together in a more efficient way. And this is the result of that. You can see I've included a link there. It's just construction.autodesk.com. I've taken a screenshot to show you where the design license would fit in. That's what you can see over here. So this is the typical sort of license that most or many of our clients have bought into. Just before the lockdown, a very large architect, so in Cape Town, they had over 150 people that they sent home just to keep the office safe. They're working from home, and I helped set up their hubs for all their projects, and you can see that they're all working from home, and it's a great success story for us and for them as well. and they've learned the new technology and they are using that to very good effect. It's not the only architect that has done it. Many architects have done it and have achieved success. Then there are other BIM 360, specifically BIM 360 platforms or licenses that are applicable. There's the plan license, which helps you with BIM coordination, quantification, estimation, bid management, and qualification. Then build, which is about project management, cost controls, field collaboration, quality, and safety. So that's based around the contractor. Both plan and build are based around the contractor. So when you're on site and you're actually building things, having those digital models on the cloud allow you to do things like installation checklists, quality control, quality assurance, even maintenance, and ultimately if you have an inspector that goes and sees everything all right, can the contractor or the subcontractor be paid? And all of those are based off the models, regardless of whether you've got a Revit model or a Plant 3D or a Civil 3D model, it's all based on the same technology. So all of that is available to us. And then ultimately our goal with most projects is to get into the operational phase where we do operational maintenance, doing things like with 5G coming up, having transducers, which gives us information about things like, for instance, if you have a chiller on a roof, it's consuming electricity. We measure the electricity that goes into that chiller, and once the chiller starts using too much electricity, we understand that some mechanical component is now becoming obsolete or old, needs to be serviced, needs to be replaced, and then we can, of course, get that feedback from the component itself to say, well, based on what we measure, something is wrong, we need to go and fix that. Ultimately, this feedback of information informs typical building of the type that we're looking at, and can also help plan infrastructure into the future by looking at the data that a building generates. So for a typical building, these are the amount of highways for traffic, for water, for electricity that we will need in the future. So all of this is very important for data capture, data analysis. A lot of job descriptions are built around that, but where we find ourselves, typically our clients find ourselves at the moment, is during the design phase, and some of them during the build and planning phase. With exception, they are in the operational phase, and what you'll find is, I know of one mining house, for instance, that is using Aconex to do that, but the models were still designed in Autodesk software. So that's very powerful. Then they've got additional products on here, which you can find. It's called Assemble, Building Connected, Plan Grid, and Pipe. So these were all included or acquired by Autodesk and are now getting developed and used by companies all around the world. So it's a very exciting field. You will find, if you follow the link there, then you can see what that Autodesk Construction Cloud looks like. If you want to learn about that, you can click on any one of these products and learn about the products. You can see the types of solutions, or what type of firm you are working, and what it is that Autodesk is doing in the background. So this is where the rest of the world is going. It's where some of South Africa is going. Some companies are doing really well. Other companies are getting on board and developing in a way that we see the cloud working to our advantage. So ultimately, what I'm saying by showing you this is that the I just want to get the PowerPoint back, is that the cloud-based solutions, or the one source of truth, is used in a very big way around the maintenance of a project from conception through to deconstruction. So over a time period of, say, 50 to 80 years, it's all relevant because of the models that we build up, and we try and put those on the cloud. And that's why we do that, so that we can manage the process using mobile apps and other technology to interface with the digital models. I've already mentioned that something like Oracle Aconex works only with IFC. The Construction Cloud is a little bit different in that a lot of the licenses allow for many of the Autodesk applications to be used in a collaborative fashion on the cloud, notably Revit, Civil 3D, and Plant 3D. So I know we've got one attendee that is working for a mining house and they use Plant 3D. As I've explained to him, my personal responsibility at Micrographics is from an architecture, engineering and construction point of view, where in our company at least, the mechanical part of that, the Plant 3D part of that, I have a colleague that specializes in that. So if there are any of you that are attending and you would like us to get in touch with you afterwards, please let me know. I can get my colleague Quinn to give you a call and to discuss exactly what you need. He's a specialist in Plant 3D, and he does try the software also on BIM 360, so he's perfectly situated to give you the best advice. I know what it does, but I don't work with it from a day-to-day perspective. So unfortunately, if I don't meet the expectations that you have from this webinar with regards to Plant 3D, I've already spoken to one of the attendees, and I will do my very best to get you the information that you need and the meeting that you need to understand exactly what to do there. That doesn't mean that the webinar is irrelevant to your understanding of what we do, but just understand that it is a specific piece of software which we can say also is available on BIM 360. We can save the file on there. It creates the database, the SQL Server database on the BIM 360 platform, and as long as it's on there, anybody within the team will be able to access that file. So what's interesting about BIM 360 is that although IFC is also supported, that's the most common one that the other common data environments use, you can also host other file types. So something like Microsoft Excel and Microsoft Word, if you have documents that you need to share with your team, if you have Office 365, you can even run it off the web browser. So as long as you put a web browser, you can open your Word document, you can open your Excel document and input information. And you can see how much it can support. We've got anything from Rhino. I'll just highlight some of the more interesting one. Rhino, 3ds Max. We've got Katia even from SolidWorks or Dassault. There's MicroStation, Bentley MicroStation. There's Microsoft Word. Green XML files for the guys that are into your HVAC and your energy analysis. There is inventor assemblies that you can put on there, images, inventor parts, Siemens software, Katia, Wavefront. So you can see pretty much everything is on there from a modeling point of view. It doesn't mean that the files are necessarily going to be collaborative, but you can store the files there for whoever is out there. And as long as you lock the file while you're on the platform, you will be the exclusive owner of that. So what we have found with some of these file types is that BIM 360 does not lock it automatically when you open it. So in other words, you and another person would be able to open it at the same time, and the first person to save back gets ownership of that file. So it's just something to be aware of. It's not exactly like some of you might be familiar with Vault, which is Autodesk platform, which it's a express sort of check-in, check-out system that is not quite yet there. But it is a work in progress, and we'll see where that goes. Then, with regards to other files that you can see here, you can have Access, Excel, Word, so lots and lots and lots of file types that you can store on this platform. You're not just limited to the sort of files that Revit can generate. You can also have a lot of other information there. I know I've worked with Word and Excel quite a lot on the platform, and it is very useful just to store the information in one place. The metadata for files are also available, so you're allowed to create attributes for your files, which you can then populate. And what we do on Revit is we print to PDF, and as soon as you print to PDF, the cloud can extract using object character recognition the metadata from the printed files that you upload. So for something like sheets, markups, creating design issues to assign to other people, it's very useful, and the metadata is extracted automatically. So the metadata doesn't travel with the file if you download it, but it sits on the cloud. That's another reason why you need access to the cloud, so you can immediately also see the other information, the metadata for that file that is up there. The locking of files, like I mentioned, is not automatic for some, but it is for others. Revit, for instance, it's a collaborative process. I think Civil 3D also locks itself, if I remember correctly. Then the design collaboration license, like I mentioned, is a huge success, and it allows you to collaborate with other people around the world on projects. That's interesting, not only from a point of view of, oh, look what the software can do. It's also interesting in the sense that earlier this year we found that some architects didn't have work and other architects did have work, and they would borrow, for want of a better word, each other's architects to work on projects as the work came in. So because the license allows you to join the team of somebody else by bringing your own license, the design license is bring your own license, you can then join projects. I've personally was involved in a project in Western Australia where the participants were here in Melfort, where I'm based. There was one other person. There was somebody in Western Australia, somebody in Cyprus, and somebody else as well, which I think they were in Greece or some other place. But all of us could work together. It's just that we had to wake up late at night or early in the morning to attend the meetings, and beyond that it was just getting the work done. So there's also an opportunity to become involved in projects around the world to extend your portfolio beyond the borders of South Africa and then to be in direct communication with each other. Why do we work in silos? What is a silo? A silo is typically the discipline that we refer to. So your structural, architectural, MEP. In the mining industry, probably your piping would be one of these. And what we find is that we tend to work in a collaborative file where various different people are working together on the structural or on the central model. That's in a LAN environment. You can also extend this onto the cloud. On a Plant 3D, I do not think you would have multiple people that can work on one file at the same time. But I know, for instance, for Civil 3D, that's true of a local area network as well. But on Civil 3D, what we are able to do is to create data shortcuts to things like topographies, elevations, alignments, and the like, where each one of those can be represented as a separate file, which then makes up the ultimate infrastructure project. So in mining, they also use Civil 3D, so that, at least from my perspective, is something where collaboration is possible. The data shortcuts can be saved onto the cloud. They are XML files and are hosted on the cloud. There's a big reason why you wouldn't want an architect to be able to modify the model of a structural engineer. So it's not a case of, usually in a collaborative environment, you trust the people that work with you. I've never come across a situation in South Africa where there was a willful act of sabotage against somebody else's model. So what I would say is that it happens by accident. And I've experienced this on this MEP project. When I first joined, the guys were in a rush. I was not the BIM manager, but it was said to me, okay, let's just model up the pipes in the architectural model. Very bad choice, because the model was quite large and it was difficult to model the pipes and the fittings in the sense that they're difficult to select. And so what happened was I had to take responsibility ultimately for deleting some groups of rooms, rooms that were grouped and put into the model, and deleting even a sidewalk. And we had to restore the model and so on. And I said to the guys, look, this is never going to work. It's not that I'm doing this on purpose. It's happening by accident. I'm trying my level best not to select your elements, but it's happening. So unless you want further complications and chaos in your model, let's split the models from each other. Let's link them in. And that achieved great success, because not only was the model more responsive, but I was unable to delete the architect's elements. Now, while that is irritating, what would be catastrophic is if an architect had to delete a structural column or a beam and the building falls down as a result of that. So the structural engineer has to take ownership of his model, the MEP engineer has to take ownership of their model, and any other discipline that's involved, especially where it's critical to the building's integrity, must have total control and ownership of their model. And that is good practice. That is one of the reasons why these BIM protocols are set up, and we understand that from the beginning of the project. The direct link that you see here on the outside of the middle circle is a shared environment. In our case, that would be BIM 360 Docs, which is on the cloud. That is the common data environment. And then you find that in some cases, let's suppose you take the MEP and the architect might just have a need for one of the mechanical engineers to come and put the fire ratings on their doors. And he would then want to give access to the MEP person that's busy modeling here, just to say, right, listen, local A, just come into my model and put the fire ratings on my doors. And the BIM 360 design license even allows you to do that. So while this is an at-risk practice, you must, strictly speaking, if you were acting towards a very strict BIM protocol, you wouldn't be allowed to do this. But the license does allow you to invite somebody else onto your project, especially if you know that the chances that they are accidentally going to alter your model is slim. Then you say, all right, come in, put the fire ratings on my doors, and when they're done with that, then you revoke their access again, and then you're on your own again with your own team. So that's a great workflow as well. You can do work at risk. You can link in the files at risk, but it is typically not advised. Instead, what we like doing is to share the models into the common data environment. So once every 2 weeks or once every week, each one of us or all of us, we would share our model through a BIM manager into the common data environment, and then the other disciplines can link that model back into their model. So the MEP guy can then link in the latest architectural and structural shares, and the same thing with the architectural silo. They can share in the structural and the MEP shares, and that's how we do it. So what's great about BIM 360 is that there is even an automated clash detection that can be set up. That's what we call BIM 360 coordinate. And as the models are shared with the other teams, clash detection is automatically updated. So the BIM managers from each silo can immediately see what impact the other disciplines' models will have on theirs. And that's huge. That is a very, very big advantage because it gives that BIM manager a heads up to see, oops, the structural engineers just shared his model with me and suddenly I've got 1,000 clashes in my model. So I can expect there to be quite a bit of work coming up in the next week. But let's just wait for the final clash report before we do something about it, or perhaps I can just chat to the guy and sort it out now, get my team busy with it. So at least you know what's coming, right? And that's nice. So we do this sort of clash detection. That's where we save 1/5 of the construction cost of a building historically. In the 60s and 70s, 1/5 of what we save today was wasted on clash detections on site, where we have to stop everything on site and say, right, here's a problem with the building, now fix it. The day before the problem gets to the construction manager, we've already fixed the problem. So huge, huge savings that can be made on built assets, and this is great. So also model complexity. As soon as you find that you're in a vertically integrated model, in my case, it would have been MEP in architectural working together in the same model. Not only did I ended up deleting architectural models, I also had to set up my own views, my own sheets, my own styles, and all sorts of things that I needed, which the architects didn't. And then you find the model becomes quite complex. And as it grows, it because you've got more than one discipline in the model, it also grows much faster, 2 or 3 times as fast as what it should, and then the model size becomes unmanageable. Lastly, you'll find that some people work in silos. It's not something that we encourage in the industry. In fact, we do just the opposite. We tend to want to democratize the models or to share the models with everybody else. And so if that is an issue, then we typically export to IFC, to the Industry Foundation class. And the reason for that is that the IFC model is non-editable. It has the solid elements that you've modeled, so the geometry of the model is there. The individual elements are accessible through a platform like Navisworks, or even within the common data itself, so you can read the properties, but at the same time nobody can edit it or save that block, save that component that you've modeled, or save that Revit family, whatever platform you're working in. They cannot save that into their own file and just reverse engineer it at the drop of a hat. They need to do a lot of work before they can get your intellectual property out of that model. Yet another advantage of IFC, and those of you that have any experience with Revit will know this, Revit, for instance, is not backwards compatible. You can't open a Revit 2020 file in 2019 is what that means. But if you export it to an IFC, at least you will have the geometry and the information within the model available to you if you link it into an older model. So that is a way that some of our clients have also found great advantage of being able to do an IFC export. That said, remember that different software vendors can also export to IFC. So what IFC is, in essence, it is the equivalent of a drawing exchange file or a DXF file that we are used to with CAD. And that is now just for databases. So it's an XML-based file that can be interpreted in conjunction with solid geometry, which is usually a step file. So it's a step file with information attached to the geometry, non-editable. So that's why we stay in silos. Then the roles and responsibilities are very important because everybody must understand what their role and responsibility is, especially where the model are concerned and how they're shared. Too often you find that one person knows everything and has to do everything while everybody else slacks off and just does the modeling or does something, you know. So we like to define these things quite detailed. The typical sort of roles that you find within a production office will be your BIM manager, your BIM coordinator, and your BIM modeler. And there you can see that some of their roles, like the BIM manager, for instance, would be responsible for the corporate objectives, so literally where the company is going with its BIM protocol, with its BIM management. The research, if there's research to be done, so what scripts can you run? Can you write a little Dynamo thing to automate something? Whatever it is that you want to do in your research, are there add-ins to add onto Revit that can help you? There's a lot of research that goes into trying to make the processes more manageable. And then process in the workflow, how do we do things, how do we structure models, how do we name things, how do we do this, how do we do that? And then also creating the standards to which, and it's a living document really, the standards is a living document for the company to say, right, this is how we do things, and this is how we do things on this project. And in reverse, if you become involved in a project where you are not the principal agent, then this is how we fit into their workflow, so I need to adjust my models to be able to fit into their workflow. And that's the BIM manager's role. To some, they can also do the implementation, so they're responsible for the implementation. So all of that is the BIM manager, and only the BIM manager. And then lastly, we get to training, the execution plan for the project, the model audit, and that's now where the BIM manager is no longer involved. That becomes the BIM coordinator's job. So when you get to the model audit, that's the BIM coordinator. Model coordination, clash detection, in other words, BIM coordinator. Content created, BIM coordinator. Modeling and to some extent drawing production. So at the bottom over here with the BIM modeler, they're going to be in modeling and drawing production, not so much the rest of these, right? So I seem not to have filled those in. But that would be no, 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 until you get right to the very end where it says modeling and drawing production. So each person will have different roles and responsibilities. If you're in a small company, you'll tend to find that you have to do all of these things, and that's difficult because it's an enormous amount of work. So there's also an opportunity to employ somebody to be able to do this for you or to work with you so you can get good. Now that's in a drawing environment, but if we look at the process in a bigger sense, so this is taken from PAS number 192 documentation, which is the British protocol, and although it's been superseded now by ISO 19560, the ISO standard, it's still very heavily based on the on this standard that I'm showing you now, it is also a living document and it's changing as time goes by. But you can see here at the top the roles and responsibilities. What we've got coordination management. So that's hugely important to the design team. So you can see this as the design team, and then over here, the information management part of it, that's very important to the contractor side of things. So when you get to maintenance and Kobe and the like, then we're going to have to input information. For instance, who installed the component? What is the warranty on that component, etc. And we would like that, what's the maintenance schedule? What's the checklist when we install this component? And so on and so forth. So we like to capture the information during construction, but during the design, the coordination management, in other words, the clash detection, making sure that everything is in the right ownership, what have you, that's very important. But in both of these, we've got this design lead and the contractor lead, and then we've got this thing that we call a task team. So a task team is typically a team that is assigned to a specific thing. The architect would have to design the architecture of the building. The MEP engineer would have to design the drainage, the stormwater runoff, the plumbing, whatever it is that they must do, they must do. And a nice complex example would be a hospital where you've got so many different sorts of gases and fluids that are flowing all over the place. Anything from peristaltic pumps for blood and operating theatre through to nitrogen and what have you. But that's basically where it comes in. So we've got a task team manager. That would be your BIM manager. You could be BIM authors. And then you've got, beyond that, you've got task information managers, very important, information managers, and also the interface manager. Now, that would be something like somebody else is working in Bentley, I'm working in Revit. Now, how do we interface that with each other? That's on the supply chain. And on the employer side, we like to have an employer's representative. So when we think of an employer, what an overseas person would typically think of as an employer would be their government, because they're the person or the entity that spends the most money on requisitioning these projects. And then, but they would have a technical advisor or a resident engineer, if it comes to the engineering side to it, that mandate what the supply chain must give them. All right, so this is how we understand our role and responsibility within that. And one of the things that I'd like to show you is just what that might look like. So I scroll just down a little bit, then you would see over here. On the information management side of it, let's just focus on one role at a time. That person must be able to enable reliable information exchange through a common data environment. Now, that's something that we've just talked about. What is a common data environment? They must maintain and receive information into the information model. So as the model is being populated, the information would either sit in the model on the cloud, or it would be sitting in metadata or in a spreadsheet somewhere, but that information must be recorded hopefully on the cloud within the digital twin. The integration and coordination of information within an information model, the configuration and importation for project outputs, and populate the information exchange format for the information model, and it goes on. To accept and reject, and there's also make a judgment call on information exchange within the common data environment, and they've got no design responsibility or right to issue instructions. All right. So each person within this process would have to understand what their role is. Project delivery management, lead design, task team manager, the task information manager, the interface manager, and the information originator. And this is how the British envisioned this some time back when they did the PAS 1192 standards. But it's a great guide to sort of imagine a job description for somebody and to say, this is your job. Your job is not to do everything. Your job is to make sure that this is correct with respect to the model, and then stick to it. So if it's not your job, then you say, it's not my job. It's not to be obtuse about it, but just that everybody understand what their role and responsibility is and pull their fair share and make sure that the models are. All right, so that's the roles and responsibilities. The advantages of BIM 360 and BIM 360 Coordinate, real-time collaboration and revenue using BIM 360 Design. There's a few things that don't work as with land-based central models, such as custom materials. That takes a bit of a workaround. You can't write groups out to models, and you can't use site locations as you can with on land. File names very importantly, should not be changed, as naming the sheets and documents are important, and updating the revisions can be done at Wikidata from OCR or PDF. So it's kind of diving into the details of things, but essentially the file keeps a history, and you can compare earlier versions to the current version, provided that you keep the name constant. So that's just something to take into account when you start working on a platform. And then also BIM Level 2 workflows are accommodated within the sharing of packages, and that's very important within the workflow within the UK or some company like that. If you become involved in the UK on a project, then you would have to work according to BIM Level 2 if you work for the government, and so we must just make sure that we can do that. And then automatic clash detection with BIM 360 Coordinate. Once the clash views have been set up, they're updated immediately on sharing of packages. Works very much like the old glue within BIM 360. You can still access glue. By the way, we've got one client who does passenger ships and high-end yachts, super yachts, and they actually use glue on a distributed team all around the world to do their clash detection and their BIM for ships, right? Because the ship is really just a building, and then giving BIM managers access to give them the ability to see developing clashes before we've already discussed that. So it's just nice to see what's on the horizon, so that we can see how we're going to clash. What that looks like, just very quickly. So I see we've got my volume is low. Sorry about that. Let's see if I can switch that up. I'm hoping this is better now. This is about as loud as I can get it. So sorry about that. I only saw the message now. Just to carry on, this is what the BIM 360 document management platform looks like. It's got various modules included in here depending on the licenses that you buy, and the sharing of packages. Here you can see sharing of packages between the different disciplines. You can share the files with each other. Not all the files are going to be included in this package sharing. Something like a DWG or a PDF or something like that you would be able to include, but I doubt if every file type that I showed you there is possible. And this is also where the automation of the clash detection comes in. So if you look at a specific clash, for instance, then let's just go back to that one. There you can see what the clash looks like. And orbit a bit, and if you select this, so this is a clash between the models. And if you click on this element, you can even see the information that you are recording against that object. So this is between a structural model and an architectural model, and there you can see how the beam is impacting the wall, and so we would like the architect to go and cut that out of his profile. So this is very useful. Especially important also with ducts and structural walls, but that we can do between the models, and once it's set up, it happens automatically. So that's wonderful. Right. Then preparing a model for sharing. It sounds difficult, but it really isn't. I would say in the extreme sense, if you're stuck for time, just delete all the views, delete all the sheets from a Revit model, for instance. Leave yourself with just the 3D and the information that's required in there with all of your components or families purged from the model. So you make the model as lightweight as possible, including the 3D, so you can do clash detection where necessary, and then the information that needs to go with it. Right. Now, typically there's a bit of a checklist that, or something that looks like a checklist. I'd like to show you what something like that would look like. So this is also from the UK. This is a model validation checklist, and there you can see some of the things that you would have to do. You could say that the model file name conforms to the standards. That's a typical thing where people get confused as what the files are. That this is a Revit thing, the protocol saving to a central file. Fix all warnings if you can. Check that all families conform to the naming convention. Check that the line styles conform to standard naming conventions. That all the content is correct. That the model is assembled through visual inspection. So do have a visual look at the thing. If are phasing and design options used, and if so, state them. Update the model matrix if required. So basically a process diagram for how the model fits together. update the revisions on the splash sheet, and then open the central, remove non-transmittable linked files, remove all required views, legend sheets, sweeps, and what have you. Remove unwanted design options, purge model, update save to central, and save to publish. So this is a checklist. That's a typical sort of checklist. So the guy that's responsible for sharing the model must go through each one of these steps and put a check there and say, I've done this, I've done this, I've done this, I've done all of these things, and now finally the model is ready for sharing. And that's the mentality that we have to think about when we think about how we manage the process. That's a typical example of a sort of checklist that you have to go through. What we found is that publishing a model with the other models linked in results in very large files that's on cloud. It's easier just to have one party linking everything in for everybody else to see, and everybody else publishes just their own file. That's what we're stating over here. And then one can also use Dynamo and BIM interoperability tools, model checker, to verify that the information is before sharing. So a lot of this stuff can be automated. So that is something from a week to week. You know, if you're there on a Friday and you know that you're going to have to spend your Saturday morning checking the models before you share it with somebody else, or you're going to have to work through the evening on a Thursday so that everybody can have the model on a Friday, and if you can do it within 30 minutes using a few Dynamo scripts and a bit of model checking, then why wouldn't you? So that's something that can be automated to some extent, and that is very useful. And just to show you what that looks like, I know we're sort of short of time. I'll just show you where to find it. If you look at your BIM interoperability tools within Revit, you'll find that you've got this that they call the model checker. The model checker, there you can see where you can set the model checker up, and you can also run it and view a report. And the setup, you can, right? So do go and have a play with this, and then you go and see if you can make some automated model checks in here. You can also set up your own model checks. There you can see some of the public library where other people have used it. You can even see the US Army Corps, their requirements. Okay, so yeah. Okay. And then one can also run it, and that will then run against this model. You'll also be able to set your own up. And there you can see the checks that they perform. Right, so definitely something to look into so that you can check the models automatically. Very useful from, and then Dynamo as well. We won't go into that during this session, but it's built into Revit. It's also part of some other files, but it's not automated for Plant 3D, for instance, as far as I know. What is it? IFC? I've already said that it's a non-editable file. It can be hosted on BIM 360 as well. It's great for clash detection, and one can use Dynamo and BIM interoperability. Yeah, so that's just the previous slide. Sorry, I got the heading wrong there. I seem to have mixed up that slide, but let me just show you quickly here on Revit. If you want to export the file to IFC, you should also have some exporters that you can put into Plant 3D. Then you can export this to an IFC file. And there are various formats for IFC files. They're used for different reasons. There you can see all the different IFC files, and if you modify the setup, then you can see exactly what's happening over here, what it is that you're doing in here. Right. So again, depending on the project that you're working on, you will find that these are very specific requirements, classification settings, and the like. Right. So one would just have to go through the setup and make sure that everything is set up correctly, and then export the file to IFC format. After that, it's not editable, and you can share that with the project team. So that's really what this webinar, what we have time for. I'd like to, like I said, just like to extend the opportunity to anybody that'd like to ask questions afterwards to send me a mail. You can get hold of me at Micrographics. I'm paul@micrographics.co.za. And I hope that you guys have enjoyed the webinar. Please feel free to send us some feedback or if you have any questions. And please also stay safe during COVID. So I'm going to stop the recording now. And so thanks very much. So I don't know if anybody has any questions at the moment, please ask. I'll see if I can field them within the minutes that we've got left.
On my side, I don't really have a question because it's just an overall view of what BIM 360 can actually do for us. Can you contact me with the guy that you actually spoke about earlier?
Is that Lebo?
Yes, it's Lebo.
Lebo, I'm going to ask him to phone you at the earliest opportunity. I know that he's perfectly, he knows exactly the type of workflows that you guys are busy with. So because he's on the mechanical side, on the mining side, perfect. When we do work together from time to time, if there's Civil 3D or Revit involved, and sometimes there is on a mine, but when it comes to Plant 3D, definitely Quinn is the expert within our company that will be able to assist you then.
Okay, please do.
Will do, Lebo.
Okay, thanks.
All right, everybody else, have a great weekend, and I hope to speak to you all soon.